We're going to be working with solving systems of equations using substitution. So once again, systems of equations is where we have more than one equation and we're trying to find whether or not they have a common point that they share. So in this part of the lesson, we'll be solving a system of linear equations using the following steps. We're going to solve one of the equations for one of the variables, and it doesn't matter if we do x or y. Then we're going to substitute into the expression from step one into the other equation. And then once we solve for that variable, we will then also substitute in a second time for that letter to find the x and the y. So here, if we notice in our original equation here, we already have y solved. So we already know that y equals 2x minus 4. So what we're going to do is we're going to go ahead and substitute in this part of the equation where y is. So I'm going to actually substitute it in there. So now if I rewrite that bottom equation, I have 7x minus 2. And then in a parenthesis, I'm going to put what y was worth because this y is equal to 2x minus 4. So we're going to write 2x minus 4 and then equals 5. Now we're going to go ahead and solve because the only variable that we have involved in this equation is x. Key thing to remember when you're solving these, if you have to distribute, remember to take the symbol that is with it. In the second part of this lesson, we'll be working some algebraic solutions, and from there on, you'll be able to choose which one you prefer. So we're going to go ahead and distribute. Remember, when we distribute, we multiply, so we have 7x still. Negative 2 times 2 would give me negative 4 with an x behind it. And negative 2 times a negative 4 would give me a positive 8 equals 5. Okay, so now we're into a multi-step equation. So we did our distribution. Now we're going to combine like terms. So we're going to go ahead and combine these together. Okay, so this is jumping us clear back to chapter 1 and reviewing those multi-step equation steps. So because the 7x and the negative 4x are on the same side of the equal sign, we're going to go ahead and just read it as 7x minus 4x. So 7 minus 4 would give us 3x plus 8 equals 5. Okay, now we're to a two-step equation. So our next step, well, we want to isolate and get that x by itself. So we're going to go ahead and leave this there, and we're going to get rid of the non-x by doing a minus 8. Minus 8. I now have 3x equals 5 minus 8 gives me a negative 3. And if you're not comfortable with integers, I highly recommend going through and checking with a calculator. So now I'm going to go ahead and divide by 3 to get x by itself. Divide by 3. Negative 3 divided by 3 gives me x equals negative 1. So I just found out in my xy combination that my x is negative 1. Okay, so now that I know x, I can choose either of these equations that were my original equations, and I'm going to go ahead and substitute in. So I'm going to go ahead and substitute into this one right here because that already has y isolated. So if I put my negative 1 in where x is in that equation, I'm going to find out what y equals. So y equals 2. X was negative 1, and notice I put that in a parenthesis, so I would remind myself that it's not 2 minus 1, it's 2 times a negative 1, and then a minus 4. Okay, so 2 times negative 1 gives me negative 2, and then minus 4 would give me negative 6. So I just found out that my combination is negative 1 comma negative 6. And if I were to go through and graph that, I would see on my graph that it's going to intersect at negative, these two lines are going to intersect at negative 1, negative 6. So this is another method. You're going to learn multiple methods to solving systems of equations. Sometimes there are certain methods that are faster just based on the equations that you're given versus others. So right now we're just going to focus on substitution and practicing that, and then we will also work on solving algebraically. Okay, so let's try another one. So here I have an equation where it's telling me that x equals something. So notice on that previous one, if I pull that back out, that we had a y equals. Okay, it doesn't matter whether they give us a y equals or an x equals, or we want to go through and get something isolated. It does not matter which one we substitute in for. Okay, so since I know that x equals 5y plus 3, we're going to take this equation and rewrite it. But wherever I have x, I'm going to put this 5y plus 3. Okay? All right, so let's go ahead and rewrite that bottom equation. 2, and then x was worth 5y plus 3. Okay, now I have to finish writing the rest of this equation. Plus 4y equals negative 1. So you'll see I now have y's involved in this equation. So that was our first step. Well, we already had it solved, so that was the first step. The second step was we went ahead and substituted in, so we've done that. So now we're going to go ahead and solve for that part of it. So we're still in the back part of that step 2. So we're going to distribute. Okay, distribution is multiplying. So 2 times 5 gives me 10y. 2 times 3 is 6, so plus 6. And then I'm going to write the rest of the equation. Plus 4y equals negative 1. Okay, so now looking at what I have there, I've got a y and then another y. So these are on the same side of the equal sign. So a very common mistake is you guys are used to always doing opposites when you're trying to move. Well, because these are on the same side, we're going to go ahead and look at it as 10y plus 4y. Because they're on the same side of the equal sign, we don't do the opposite yet. That's when we move to the opposite side. So 10 plus 4 gives me 14y, and then I still have a plus 6 equals negative 1. Okay, so now we're going to go ahead and we want to work to get that y by itself. So that has to stay, so we have to get rid of anything else. So we're going to get rid of this positive 6 by doing a negative 6 minus 6. I now have 14y equals negative 1 minus 6 gives me a negative 7. Okay, so now to get y by itself, we'll divide by 14. Divide by 14. I get y equals negative 7 over 14, or y equals negative 1/2. Now, because we're doing some substitution, you might want to change that to a decimal number because it'll be easier to substitute in, but I will leave that up to you. So in my x and my y combination, I just found out that y is negative 1/2. Now, I'm going to choose, as I go through to do this, to actually substitute in as a 0.5. Okay, so I'm going to look at that y as a negative 0.5 when I substitute it in. Okay, so I'm going to erase this. And I'm now going to use this top equation because that already has x isolated. And I want to find out what x is. So x is or equals 5 times y, which I said I'm going to use the negative 0.5, and then plus 3. Okay, so here is where I would recommend use that calculator if you need it. Okay, I don't want you to go through and make a basic mistake at this point. I would prefer you to go ahead and use your calculator if you really need it. Okay, so if I go through and do this, 5 times 0.5 is going to give me 2.5. So I had a negative there, so it'd be a negative 2.5 plus 3. Okay, so now when I add those together, negative 2.5 plus 3, different symbols find the difference, so I'd subtract is going to give me 0.5. The larger number is positive. So I found out that x is a positive 1/2 or a positive 0.5. Okay, so you could either write it out in fraction form or you could write it in decimal. But I know with slope, you guys are used to working fractions. Okay, so if you were to go through and actually graph this, you would see that they would intersect at a positive 1/2 and a negative 1/2 y. Okay, so let's try another one. Okay, substitution it is. Systems of equations, it takes time to go through and actually solve these. Okay, so here we have 2 equations. So our first step is we want to go through and solve for one of the letters. Well, I'm noticing y is already isolated there. So I already know what y is. So that first part's done. Now we're going to substitute in to that equation, this bottom equation into my top equation. So that's my y. So I've got 4x plus 2, and my y is 1/2 x minus 5. Now, if you would prefer, you could look at this as 0.5x minus 5, because we're just going through to solve for other numbers. We're not going through to actually be able to graph these. So we're trying to find our x-y intersection. So I'm going to use this as a 0.5x. So 0.5x minus 5. And then I still have the equals 0. And I know sometimes what happens is you get so busy substituting in, you forget to write part of the equation. So make sure you have the whole equation written. So sometimes it might be smart too to just write the equation and put a parenthesis for the letter and then go back in and substitute in. Okay, so first step, I'm seeing parentheses. So I want to do my distribution. So I still have a 4x, and a plus 2 times 0.5 is going to give me a 1x, and then 2 times 5 is 10, and there was a negative sign there, so minus 10 equals 0. Okay, so that was step 1, going through and doing our distribution. Okay, so now we're going to go ahead and combine like terms. So I'm seeing x's here. They're on the same side, so we're going to go ahead and just put them together, not doing the opposite. So 4 plus 1 gives me 5x minus 10 equals 0. Okay, so now we're to a 2-step. So we get rid of anything that's not connected to the variable, so that's going to stay. So we're going to do a plus 10, doing the opposite now because we're going to the opposite side of the equal sign. Okay, so I have 5x equals 0 plus 10 is 10. And now we're going to go ahead and divide by 5 to get the x by itself. So I just found out that my x equals 10 divided by 5 is 2. So in my x-y combination, my x is 2. Okay, so now we're going to do, that was step 2. We're now going to go through and substitute in to our isolated equation. So we're going to use that y equals equation because we want to find out what y equals. So we're going to substitute into this equation right here. Okay, so y equals, we found out it's 1/2, so I'm going to use 0.5 times, well, we know that x is 2 minus 5. Okay, so take note, I copied this except for I changed that fraction to a decimal. Otherwise, I copied it the same and I substituted in what we just found out x was. Okay, so 0.5 times 2 is going to give me 1. So 1 minus 5 is y equals -4. So my system of equations answer is 2, -4. And if we were to graph it, that's where we would see that they intersect. Okay? All right, so last one, we have y equals and y equals. So here, it's really not going to matter. This is kind of a combination going into what we're learning in the next part of this lesson, which is what I prefer. And that's solving system of equations algebraically. To me, it's faster. But if we go through and we substitute in, it does not matter which one of these I use. So I'm going to go ahead and substitute this one in because it's less writing. So this 5x is going to go where that y is. So I have 5x equals 2x plus 3. Okay, so now we're going to work to get our x's on one side. So take note, on this one, we have x's on both sides of the equal sign. So because I'm going to put them together and I'm moving to the opposite side of the equal sign, I have to do the opposite. So it really wouldn't matter which one I moved, but I want to get x's on one side and non-x's on the other. So I'm going to move this 2x by doing the opposite. Right now it's a positive 2x, so I'm going to do a minus 2x or a negative 2x. 5 minus 2 is 3x equals 3. Now we'll divide by 3 to do the opposite. 3 divided by 3 is 1. So I just found out in my XY combination that X is 1. Okay, now here's where it's totally up to you. You can substitute in once again into either of these equations. I'm going to choose to substitute into this one, and here's why. Because y equals 5 times 1. It's a one-step process. 5 times 1 is going to give me 5. So here's my solution to my system of equations. Now, had I substituted into the other equation, we should still get 5. So if I put a 1 in this spot right here, 2 times 1 is 2 plus 3 still gives me 5. So take note, it doesn't matter which of those two equations I substitute into because both of them say y equals. Okay, so that's basically it for this part of the lesson. You guys will be working with some algebraic in the next part. And then from there on out, you kind of get to pick which one you prefer. It's totally up to you. I know substitution sometimes is beneficial and sometimes it's just as much work or sometimes more work than some of the other processes that you'll learn. Good luck with this lesson.